Hi students, this is PHANI. Welcome back to my channel. Now I am going to discuss the very important topic for JEE Main and Advance, that is circles, in one class. So all the concepts in circles now I am going to explain in one class. If you like this video, you share to your friends and subscribe to my channel. Now I am going to start the circles, the major important concepts in circles. Let us see the points. First one, equation of circles. There are different ways to find the equation of circles. So one is, let us suppose the center is alpha comma beta and point on the circle is x comma y. So the distance is nothing but r. So whenever to find an equation of circle, we require two things. One is center, other one is radius. If you know these two, we can find the equation just nothing but the equation x minus alpha whole square plus y minus beta whole square is equal to r square. This is the fundamental equation of straight lines, circles. To find the equation of circle, these are the two requirements. One is center is at alpha comma beta and radius is r. Suppose if center is at origin, that means alpha beta 0, then what about the equation x square plus y square is equal to r square. So this is represents equation of circle when center is at origin and radius is r. Okay. Now there are suppose if radius is equal to 0, this is called if radius is equal to 0, it is called point circle. That means just a point. The point has center but not the radius. But not the radius means radius becomes 0. So we can say if radius is equal to 0, that is called point circle. If radius is equal to 1, we can call it as unit circle. So there are different circles with the same center but different radii. These are the circles with the same center but different radii. These type of circles, these are the different radii. Such type of circles are known as concentric circles. You remember one important point for all the equations of concentric circles will be same except the constant. That means the equations of concentric circles are differ by a constant only. Okay. So next point. This is called a non-homogeneous second degree equation. This is one of the important point. Ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. This is called a non-homogeneous second degree equation because these three terms are with x square, y square and xy power 2, and these two terms x and y power 1, and this is constant. There is no power for x and y. Okay. So such type of equation is called general equation of non-homogeneous second degree equation. If for this one, if delta means abc plus 2fgh minus af square minus bg square minus ch square is equal to 0. If the entire value becomes 0, then this non-homogeneous second degree equation always represents a pair of straight lines. So it involves two straight lines if it becomes 0. If it doesn't equal to 0, then what happens? It will be a curve. Either it is circle, parabola, ellipse, hyperbola, whatever it is. So for the first condition, because we are going to discuss circles topics, so that's why I am telling about only circles. If delta not equal to 0, if this one is not equal to 0, it represents a circle when a is equal to b. That means x square coefficient should be equal to y square coefficient, and h means coefficient of xy should be 0 only, and coefficient of x square and coefficient of y square should be equal, and that should be equal to 1 only. Then only it represents an equation of circle. And there is one more point we have to remember, that is g square plus f square minus c should be greater than or equal to 0. If these three happen, delta not equal to 0, coefficient of x square is equal to coefficient of y square, that should be equal to 1, and h is equal to 0, that means coefficient of xy is equal to 0, and g square plus f square minus c greater than or equal to 0. If these three happen, then this non-homogeneous second degree equation always represent a circle. If by substituting these values in this equation, you will get like this, that is x square plus y square plus 2gx plus 2fy plus c is equal to 0, which is called standard form of or general form of equation of circle. General equation or general form or standard form of the circle having the center at minus g comma minus f, half of the coefficient of x and y with by changing the signs, and what about the radius? Root of g square plus f square minus c. This should be under root value always positive, then only it is a real circle. If not, it is an imaginary circle. Okay. Now this is called very important. This is the general form or standard form of circle. For center is, for this type of circle, the center is minus g comma minus f, and radius is root of g square plus f square minus c. Okay. Now there is one more equation of the circle. When ends of diameter of a circle are given, let us suppose these are the two extremities or ends of diameter of a circle. Okay. So there will be infinite number of diameters for a circle, and let us suppose I am taking one diameter whose ends are x1 y1 and x2 y2. Then the equation of the circle is nothing but x minus x1 into x minus x2 plus y minus y1 into y minus y2 is equal to 0. This is another equation, another way to find an equation of the circle. When you have to use this formula, when x1 y1 and x2 y2 are ends of diameter, then this is the formula to find an equation of circle. By observing these two, this is a quadratic equation where the roots are x1 and x2. This is one more quadratic equation where the roots are y1 and y2. So sum of the quadratic equations of in terms of x and in terms of y, that is nothing but always equal to an equation of a circle. Okay. Let us go with one more important concept, that is a concyclic point. 3 or more points lie on a circle. Suppose these 4 points lie on a circle, then the type of points are said to be concyclic points. Here is 2 more important points for concyclic points concept. I will explain those concepts also. Suppose a comma 1 by e, the points like a comma 1 by a, b comma 1 by b, c comma 1 by c, d comma 1 by d. If these 4 points lie on a circle, suppose these 4 points are concyclic points, then the condition is a into b into c into d is equal to 1. Okay. So this is one more condition. And one more important point in concyclic, that is, let us suppose these are the two straight lines. These are the two straight lines whose ends are, I will draw like this. This is one line and this one is another line. Suppose this is a circle and having these 4 points. Okay, these are the two lines, a1x plus b1y plus c1 is equal to 0. This is one line, and this one is another line, a2x plus b2y plus c2 is equal to 0, such that these two lines where the ends of the lines are on axis and such as a concyclic points, then what about the equation of this circle? Just you multiply these two equations by subtracting coefficient of xy, because in circle equation there will be no xy term. Okay, just you multiply a1x. Suppose two lines are given, a1x plus b1y plus c1 into a2x plus b2y c2. These two lines are concyclic such that their ends are on axis. Then the equation of the circle is just you multiply these two equations and subtract the xy coefficient. So there is no necessity to write xy term in the equation. This should be equal to 0, which represents equation of circle. And if these two lines are concyclic, as I said earlier, then what will be the condition? Then a1 a2 plus b1 b2 is equal to 0. So these are the 3 points which we have to remember in concyclic condition. Next, I am going to discuss about when a circle touches the x-axis, or suppose this is a circle with the center at minus g comma minus f, but I don't think that it is in first quadrant. Okay, if you think that it is a first quadrant, then g will be negative. It is not possible. So this is nothing but radius. This is nothing but radius. So actually, if it is g comma f, this value is equal to f only, because the point is g comma f and this is nothing but f, but it is radius. So when a circle touches the x-axis, then r will become modulus of f. Okay, you remember that if a circle touches the x-axis, then r is equal to f. By simplifying this one, r square is equal to f square. R square means radius for a standard circle. General form of a circle, g square plus f square minus c is equal to f square. Now g square is equal to c. You remember these two concepts, or any one of them, then you can solve the another one. So r is equal to mod f. That means if a circle touches the x-axis, remember that radius is equal to always y coordinate of the center, modulus of y coordinate, because the radius is always positive. So g square is equal to c. Okay. Suppose if g square is equal to c, it is the condition that a circle touches the x-axis. Let us suppose a circle like this. touches the x-axis at origin. You see, the circle touches the x-axis but at origin. Then what about the center? That center lie on the y-axis. Then what about the center? 0, f or 0, minus f, whatever it is. Radius is also f. So center is 0, f or 0, minus f. Radius is f. Then the equation of the circle is f square. So you will get x square plus y square plus 2fy is equal to 0. So this is the equation of a circle when a circle touches the x-axis at origin. In the same way, suppose a circle touches the y-axis, then what happens? You see here, a circle touches the y-axis like this. Here is the center, and this one is nothing but the x coordinate. Let us suppose this is g, f. This will be equal to g. Now radius is equal to mod g. If a circle touches the y-axis, radius is equal to modulus of the x coordinate of the center. And by simplifying squaring on this one, you will get f square is equal to c, which is the condition if a circle touches the y-axis. Let us suppose the circle here only. That means the circle touches the y-axis at origin. Then center will be on x-axis. Then what about the equation x square plus y square plus 2gx is equal to 0? Okay. Now, if a circle touches both the axes, then what happens? So, circle will be like this. If circle touches both the axes, that is coordinate axis, then you see this is also radius and this is also radius. So, if it is r, the length is E is also r. If it is r and r, then what about the center? That is r, r. So, whenever a circle touches both the axes, then the center is always of the form r, r, and radius is also r. Okay. Now, coming to the next point, notations. That I think everyone will know. That S is equal to general notations x square plus y square plus 2gx plus 2fy plus c, and S1 is equal to xx1 plus yy1 plus g of x plus x1 plus f of y plus y1 plus c. In the same way, you can write S2 also, and I am going to write S12, that is nothing but x1 x2 y1 y2 g of x1 plus x2 plus y of f1 plus f2 plus c, and S11 means x1 square plus y1 square plus 2gx1 plus 2fy1 plus c. These are the important, very, very important concepts. We have to remember the entire circles. These are called notations, S1 and S11s. Now, one more point. That is, suppose here is a circle with the center at C and here is a point P. Then what about the least distance from P, a point on the circle? A point on the circle means point may be anywhere of the circle. What will be the least distance from P? So this will be the least distance. And what about the maximum distance? This will be the maximum distance. Let us suppose these 2 points are P. So PB is equal to least distance, and PA, the maximum distance, PA is equal to the maximum distance. How to find the maximum and minimum distance? Let us suppose this is nothing but radius R. You see, this is nothing but CP, the distance from center to point P. So least distance is equal to CP minus, we have to find this one. So CP minus R, the total distance minus R, you will get PB, which is nothing but the least distance. Okay, so what about the maximum distance? So this is CP and this one is nothing but R. So CP plus R is called the maximum distance, okay, from a point P on a point to the circle. Next one, you see, this is also one of the point you have to remember always, that is here is a point P and here is a point P, x1, y1, and here is C. I am going to, let us suppose this point is minus g comma minus f. What about CP square minus R square? CP square, this distance minus radius square. Okay. So what about CP square? CP square means x1 plus g whole square plus y1 plus f whole square minus of g square plus f square minus c. So what you will get here? x1 square plus y1 square plus 2g x1 plus 2f y1 plus 2f y1, g square plus f square gets cancelled, and here we have minus of minus plus c, that is nothing but S11. So you remember this one, S11 is nothing but CP square minus R square. So where we can use this formula, I will explain. Next, I am going to explain position of a point. So this is I am going to explain the complete topic. You should be patient to know all the concepts in circles. So listen complete video. In one complete video, I will explain the entire concepts, whatever concepts are there and for useful for JEE Main and Advance. Okay. So P, position of a point. Position of a point with respect to a circle. So here is a circle, maybe the point outside, maybe the point on the circle, or the point inside the point. These are the three possibilities, or point may be center itself. Okay, so these are the three possibilities. Let us suppose the center will be C. So here you see the distance of CP, and this one is R. Which one is greater? CP is greater than R. From this we can say CP is greater than R. Now CP square minus R square should be greater than 0. What is meant by CP square minus R square? That is nothing but S11. So if S11 greater than 0, then the point lies outside of the circle. In the same way we can say if S11 is equal to 0, the point is on the circumference of the circle. If S11 less than 0, then the point lies inside the circle, So this is called position of the point. Next, coming to position of a line. This is one of the important concept that is for the JEE Main and Advance. Position of a line with respect to a circle. So what about the line? The line may be like this, or line may be like this, or line may be like this. These are the three possibilities. If a line cuts like this, if a line touch or neither touch nor intersect. You see, this is center and this one is the perpendicular distance. I am calling this perpendicular distance as D, and here the radius is nothing but R. You observe this one, R is less than D. What about here? This is center and this one is perpendicular distance D, and this is also nothing but radius. Here R is equal to D, and here you observe this one. This is radius perpendicular distance D, and the entire thing is nothing but R. Here R is greater than D. So these are the three important points for the tangency and secant line. Secant line means if a line cuts a circle at two distinct points, then that line is called secant line. You see, this is a line neither touch nor intersect, where radius is less than. D means the perpendicular distance. You remember this one. D is nothing but the perpendicular distance from center to the given line. So R is less than D, the line neither touch nor intersect the circle. If R is equal to D, this is very important. Tangency, the condition for tangency. If a line touches the circle, then R should be equal to D, and where the tangent line meets the circle, and the point is called point of contact. Now, if a line cuts the circle at two distinct points, then R should be greater than D, and the segment of the line is nothing but chord of the circle, and the length of the chord is nothing but 2 into root of R square minus D square. This is the length of the chord. Okay. So these are the three positions of a line with respect to a circle. This is called position of a line with respect to a circle. Now let us go with suppose a circle. I already explained you, when a circle touches the x-axis, what happens, touches the y-axis, and if touches both the axes, what happens. Then you see, if a line circle cuts the x-axis, then the part of x-axis is inside the circle, a piece of the x-axis is inside the circle. This is called X-Intercept. You see, this is center, and what about the center? I am assuming this is minus G, minus F. So this is nothing but F, and this is nothing but R. So what about this one? Root of R square minus F square. So same way, this is also R and this one is F. This is also root of R square minus F square. So the total length is nothing but 2 into root of R square minus F square. What about R square? G square plus F square minus C. So F square will be cancelled. So we will get 2 into root of G square minus C, which is called length of the X-intercept made by a circle. Okay, length of the X-intercept. This is the length of X-intercept made by a circle. This is 2 into root of G square minus C, length of X-intercept. You see, there will be three positions, like the circle may be like this, or the circle may be like this. Okay, if it cuts the x-axis or touches the x-axis or neither touch nor intersect the x-axis. Suppose this is the length of the x-intercept. From this we can say if g square minus c greater than 0 only, the circle touches the x-axis. Okay? If it is equal to 0, this will be the condition. Is equal to 0 means g square is equal to c. Now the circle touches the x-axis. If g square is less than c, so that means g square minus c is a negative value. So there will be no positive value, which means the circle neither touch nor intersect the x-axis. So in the same way, we can say that length of the y-intercept also. If a circle cuts the y-axis, this is called length of the y-intercept, whose formula is root of f square minus c. If f square minus c greater than 0, the circle cuts the y-axis. If it touches the circle, then f square is equal to c. Neither touches the x-axis nor cuts the y-axis, then f square minus c is less than 0. So that's next one. Coming to the next point, I already told you if a circle touches the line, then what about the condition? This is the condition for tangency. R is equal to D. R is equal to D. Okay? How many tangents are possible from an external point? Now I am going to discuss the very important concept, that is tangent conditions and tangent concepts in circles. The first condition is if a line touches the x-axis, what about the condition? R is equal to D. Okay? That should be the condition. A line touches the circle. Maximum 2 tangents can be drawn from an external point. I will prove and I will say very important point also. Let us suppose this is circle. Here is a point Px1, y1. And I am taking the circle as x square plus y square is equal to a square. This is, I am taking the circle center as 0, 0 because it is very simple to prove, that's why. And let us suppose one of the tangent is y is equal to mx plus c, because it is passing through this point, y1 is equal to mx1 plus c. And you see, this is perpendicular distance d and this one is radius r. Now r is equal to d. What about radius here? That is a. D means perpendicular distance from center. What is center here? 0, 0. From center to perpendicular distance to this line is nothing but mod c by root of m square plus 1. Okay? Perpendicular distance from origin to a line is nothing but mod c by root of m square plus 1. Now from here, c can be written as plus or minus a into root of m square plus 1. Okay? Now I am going to substitute here. y1 is equal to mx1 plus c. C means plus or minus a into root of m square plus 1. So y1 minus mx1 is, this is one of the very, very important concept in circles. M square plus 1. Now squaring on both the side, y1 square plus m square x1 square minus 2m x1 y1 is equal to a square m square plus a square. Now you see m square of x1 square minus a square minus 2m x1 y1 plus y1 square minus a square is equal to 0. So it is a quadratic equation in m. What is m? Here m is nothing but slope. So from this we can say that there exist two slopes, two real slopes, because it is a quadratic equation. There exist two real slopes, so we can draw two tangents. From this quadratic equation we can prove very one of the important concept. I will explain this concept also. Let us suppose m1 comma m2 are the roots of this quadratic equation. Okay, this quadratic equation in terms of m. So what about the sum of the slopes? m1 plus m2 is equal to 2x1 y1 by x1 square minus a square. And one more point, there is product of the slopes, that is m1 m2 is equal to y1 square minus a square by x1 square minus a square. So without finding the equations of tangents, we can say the sum of the slopes of these two tangents and the product of the slopes of these two tangents. These are the two important formulae we have to remember. From an external point we can draw two tangents, and the two tangents we are having two slopes. These are the two formulae to find sum of the slopes and product of the slopes. And from this we can find one important concept, that is if the tangents are perpendicular, then what happens? Tangents are perpendicular means product is equal to minus 1, slopes product. So y1 square minus a square is equal to minus x1 square plus a square. Now x1 square plus y1 square is equal to 2a square. Okay. The locus, what about the locus here? X square plus y square is equal to 2a square. This is also a circle. So from this concept I am going to say that point is this is a locus of perpendicular tangents. So this is the circle. We draw two tangents which are perpendicular. From this we draw two tangents which are perpendicular. From this point we can draw two tangents which are perpendicular. In the same way, so the locus of these point of intersections is also a circle. This is also a circle, and you see our circle is this one, the resultant is this one. So these two circles are concentric circles, and this radius is a. What about this radius? Root 2a. So the point is the locus of point of intersection of perpendicular tangents is also a circle which is concentric with the given circle and whose radius is root 2 times the radius of the given circle. So this is one of the important. I am going to explain one more time. So suppose if the tangents are perpendicular, then the locus is also a circle. This circle having the center is same as the center of the given circle, and the radius of this circle is nothing but root 2 times the radius of the given circle. Okay. In ellipse and hyperbola, that circle is called okay, remember that one? Okay, I will explain it later. Now you see these are the two tangents. In advance also many times this type of questions by using this concept some questions are given. I will explain those questions also. Let us see, this is the point x1 y1 and here is center is C and this is a tangent. This point is called point of contact. This is also known as point of contact. Okay. This is center and this one is perpendicular because it is a tangent. R is nothing but D. This is R. This is R. Okay. Now you see this is the angle between the tangents. This completely is angle between the tangents. I am going to take it is theta. Now what about this one? This is theta by 2 and this is also equal to theta by 2. This is a right angled triangle. Okay, am I right? This is right angled triangle. We know this side. What about this one? Come on, you say. Since here is 90 degrees and this one is hypotenuse. What about this PA? PA is nothing but root of hypotenuse square, that is CP square minus side square R square. I already told you. What about CP square minus R square? That is nothing but root S11. This CP square minus R square is nothing but S11. You see, this is nothing but a tangent. So from point to this point of contact, this is called length of the tangent. So we have one point, that is length of the tangent is nothing but root S11. So remember this one, length of the tangent is nothing but root S11. This is also length of the tangent. This is also equal to root S11. This is the radius. So from this figure, I am going to prove number of concepts, important concepts. You see, the first one is, you see, this line CP is nothing but the angular bisector between the tangents. These are the two tangents and this line is nothing but angular bisector between the tangents. Angular bisectors between the tangents. Now you see, you take one triangle, this triangle. What about the triangle's area? Half base into height. This is nothing but base and this one is height. So half into R into root S11. This is the area of the triangle. The same area will be here also. So area of triangle PAC is equal to area of triangle PCD. That is nothing but half into R into root S11. So what about the entire quadrilateral area? This is nothing but 2 times of the area of this one or area of this one. So R root S11 is the area of the quadrilateral PAC. Okay. Now what about the circle which passing through these 4 points? Okay, or triangle PACB. This is called Circum Circle. This there was a question given in advanced examination. The circle, to find this circle, P point is given and one circle equation is given. The circumference, the circum circle of this is nothing but, the equation of the circum circle is nothing but, you see, here is 90 degrees. Angle in a semicircle is 90. So this is a semicircle. What about this one? This is nothing but diameter. Okay, so this equation of the circle is nothing but having these 2 points are ends of diameter. So whenever a point is given, from that point we can draw 2 tangents to a circle. Then what about the equation of the circle? This one. So this circle equation is very easy to find. This equation of the circle, these 2 points and the given point and the center of the given circle are the ends of diameter of a circle. Okay, so next point. Oh, one more point. Now we have tan theta by 2. You can take from any of the triangles. From this triangle we can say, what about tan theta by 2? This is r by root s11. So remember this point, tan theta by 2 is equal to r by root s11. So I am going to find tan theta, angle between the tangents is theta. Now tan theta is equal to, formula is 2 tan theta by 2. 2 tan theta by 2 by 1 minus tan square theta by 2. So from this we will get 2r root s11 by s11 minus r square. This is the formula to find angle between the tangents. Otherwise you can directly find tan theta by 2 and you multiply with 2, then you will get the total angle. Or you can use the formula tan theta is equal to 2r root s11 by s11 minus r square. From this formula you can find sin theta also. What about sin theta? 2 tan theta by 2 by 1 plus tan square theta by 2. From this you will get sin theta is 2r root s11 by s11 plus r square. And from tan theta by 2 we can find also cos theta also. What about cos theta formula? 1 minus tan square theta by 2 by 1 plus tan square theta by 2. 1 plus r square by s11. So s11 minus r square by s11 plus r square, that is cos theta. And you see, you will get one more point here, that is tan theta by 2 is equal to r by root s1. If the tangents are perpendicular, I already told you, suppose from this also we can prove that one, theta is equal to 90 degrees. That means tangents are perpendicular. So this will be 90 by 2, 45. Tan 45 is equal to 1. 1 is equal to r by root s11. So r is equal to root s11. R is equal to root s11. Or s11 is equal to r square. So this is the condition for a two tangents. If from an external point we can draw two tangents. If those two tangents are perpendicular, then s11 is equal to r square. So this is the condition, the perpendicular tangents condition. S11 is equal to r square. Okay. Let us go with one more point. That is, you see, this is point of contact and this one is also a point of contact. By joining these two, this is called a chord. For this, the chord has another name. By joining these two point of contacts, this is called chord of contact. Chord of contact, whose equation is also S1 is equal to 0. And I forgot to find the equation of tangent. Suppose this is a tangent. This is the point of contact x1, y1, and the circle is S is equal to 0. The equation of tangent at this point is also S1 is equal to 0. So S1 is equal to 0 is an equation of tangent at the point of contact. S1 is equal to 0, equation of chord of contact where from external point. Okay, so these two equations are different. You remember the equation is same, but point is here is point is on the circumference of the circle, and here the point is outside of the circle. Okay, this is chord of contact. Equation of contact, which equation is the equation whose equation is S1 is equal to 0. Let us go with what about the area of this triangle? The area of triangle formed by the chord of contact and external point, PAB triangle. So we have a formula in the properties of triangles, solution of triangles, that is half AB sin theta. This is one of the formula to find area of triangle. So I am going to use this. This is the total triangle, half AB, one side and included angle. So half AB, root S11, root S1, sin theta. I already told you, if tan theta by 2 is equal to r by root S11, I already wrote that. That is sin theta is equal to 2r root S11 by S11 plus r square. So 2 gets cancelled. This is root S11, this is S11. So the formula area of this triangle is nothing but r into S11 power 3 by 2 by S11 plus r square. This is the area of triangle, this one. Okay. And from this also we can find the two sides also. the side length of the chord of contact. We can find the length of this chord of contact by using a formula c square is equal to a square plus b square minus 2ab cos theta. We have a formula, cosine rule is there in the properties of triangle. C square, so this chord of contact square is equal to a square, one side is square s11 and another side square root s11 square minus 2 into root s11 into root s11. I already wrote that formula cos theta, that is s11 minus r square by s11 plus r square. If you simplify this one, you will get length of the chord also, length of the chord of contact also. So this is one of the very important concept diagram. Okay, let us go with this is about tangents and pair of tangents and angle between the tangents and chord of contact also. Let us go with next. The concept is pole and polar. Pole and polar. What is meant by pole and polar? You see, this is a circle and here is a point P. The point I am taking as outside of the circumference of the circle. Now from this point we can draw infinite chords, infinite secant lines which will cut the circle at two distinct points. And this is nothing but the chord. These are the chord. The segments are chord. From the ends of the chord, I am going to draw tangents. From the ends of the tangents, chords, I am going to draw tangents. So this will be the tangents. This is the chord ends. From the end of the chords, I am going to draw tangents. And this is the point of intersection of tangents. Without confusion, I will draw only two secant lines. So this is chord. From the end of the chord, these are the tangents. And this is point of intersection of tangents. This is nothing but a straight line. Line joining the point of contact, point of intersection of tangents, it is a straight line. You see, these are all chords. From the end of chords, we can draw tangents and these are the intersections. The intersections must be lie on a straight line. That line is called polar with respect to of the point P with respect to this circle. Okay, this is called polar. Okay, the locus of a point, point of intersection of tangents drawn from an external point with respect to a circle. Okay, is a straight line which is called polar. The locus of point of intersection of tangents from the extremities of chords of a point with respect to a circle. Suppose here is a point P, point is outside of the circle, then polar cuts the circle as of the diagram. Okay, you remember these points? If pole is outside, this is called pole. Pole is outside of the circle, then polar cuts the circle at two distinct points. Suppose pole is on the circle, then polar is nothing but tangent at that point. Okay, if pole is on the circle, suppose pole is here on the circle. So these are the secant lines and this will be the tangents. You see, this is one tangent and this is one tangent. This is the point of intersection of tangents. This is tangent and this one is tangent. This is point of intersection of tangents. By joining these point of intersection, we will get a line. That line is nothing but polar. By the definition, this is nothing but a polar. But you see, the polar is nothing but like a tangent at P only. So whenever a pole is on the circumference of the circle, then polar is nothing but the tangent at that point. So that's why equation of polar is also S1 is equal to 0. Okay. Now, if pole is inside the circle, if pole is outside the circle, then polar cuts the circle. If pole is on the circle, then polar is nothing but the equation of tangent at that point. And if pole is inside the circle, then polar will be, the line will be outside of the circle, neither touch nor intersect the given circle. So these are the three important points. If pole is outside of the circle, polar cuts the circle. If pole is on the circle, polar is nothing but equation of tangent. And if pole is inside the circle, then polar is outside of the circle. That means neither touch nor intersect the circle. If pole is the center of the circle, then what happens? If pole is center of the circle, then polar does not exist. That point is very important. If pole is the center of the circle, pole is equal to center, then the tangent secant line is nothing but, this is the chord, where the tangents are parallel, they didn't intersect. That's why polar does not exist. If pole is center, then polar does not exist. I will explain now two more points for JEE main level. that is, suppose here is a point P and its polar is nothing but this one, and here is a point Q and the polar is nothing but like this. If the polars of these 2 points intersect at R, then the polar of this point is nothing but the line PQ bar. Okay, I will explain one more time. This is pole, one pole, and the polar is this one. This is another pole, the polar is this one. The polars are intersected at R. If it is pole, then the polar is nothing but PQ bar is the polar of R. Okay, that is one point. And another point is, suppose P is here and the polar is like this. If Q is here, polar is like this. If R is here, the polar is like this. If these 3 lines are concurrent, the polars of the 3 points are concurrent, then these 3 points must be collinear only. These 3 points are collinear points. Okay, these are the points about pole and polar. Okay, next, coming to the next one, inverse of a point. Inverse of a point. Inverse of a point. What is meant by inverse of a point? Suppose this is a circle with center C and here is a point P, that is nothing but pole. So since pole is outside of the circle, polar will cut the circle. But suppose if the line joining center to the pole and the polar are perpendicular, the line CP bar and polar of this point are perpendicular, and a CP into CQ. Let us suppose this is CQ, this is Q. CP into CQ is equal to R square. Okay, and P comma CQ are on the same side of C. Then we can say Q is nothing but inverse point. That is, Q is called inverse point of P with respect to the circle. This is polar. How to find inverse point? You see, this is perpendicular. As I told you, this is perpendicular. So this is like this. This is P and this one is Q. So Q is nothing but the foot of perpendicular. So it is foot of perpendicular either from P or from center to the polar. So inverse point Q is equal to foot of perpendicular from center to polar or pole to polar. Okay, so that is about inverse point. Next, the last concept is number of tangents. Okay, let us suppose these are the 2 circles. I already explained you, from an external point we can draw 2 tangents. These 2 tangents can be combined together. We can call it as a pair of tangents. Whose formula is S1 square is equal to S into S1 square. S into S11. The pair of tangents. Suppose this is the point P x1 y1 and this is the circle S is equal to 0. Then the pair of tangents whose equation is S1 square is equal to S into S11. Let us go with number of tangents if 2 circles are given. What about the conditions? Suppose the 2 circles may be like this. If 2 circles are given, the 2 circles may be like this, or 2 circles may be like this. I am drawing just one big circle and small circle because the diagram will be somewhat clear, and the circles may be intersect, or the circle may be touch like this, or the circles may be here, or the circles may be like this. These are the few shapes. One will be like this, another will be like this, or 3rd position, 4th position, and 5th and 6th. These are the 6 positions when 2 circles are given. Okay, these are the relative positions of 2 circles. We can say relative positions of 2 circles. Suppose I will go with the first one. I will explain some important points here. So suppose 2 circles are given. If the 2 circles are neither touch nor intersects, the 2 circles are away from each other, then there exist these are 2 and these are 2. These are called common tangents. You see, this is a tangent common to both the circles. These type of tangents are called direct common tangents, and these type of circles tangents are known as transverse common tangents. Okay, these are direct common tangents and these 2 are transverse common tangent. And the direct common tangents intersect the point is called external center of similitude. This point is called external center of similitude. What is meant by similitude? It's nothing but point of intersection. So this is called external center of similitude, and this point is called point of intersection of transverse common tangents. It is known as internal center of similitude. Okay, when it is possible, I will explain you. So let us suppose this is the center C1 and this is the center C2, whose radius is R1 and whose radius is R2. Okay, now you see the distance from C1 C2 is greater than that of R1 plus R2. So if the distance between any two circles is more than that of the sum of the radii of the given two circles, then the two circles neither touch nor intersect. The circles will be like this. Then there exist four common tangents. Two are direct common tangents and two are transverse common tangents. These two direct common tangents intersect at one point, that is called external center of similitude, and the transverse common tangents intersect at one point, that point is called internal center of similitude. And one of the important point here is, this is the center C1 and this is center C2. These 4 points, what about these 4 points? C1, C2, internal center of similitude and external center of similitude. The 4 points are collinear points. The 4 points lie on same line, external center. And one more point is, this internal center of similitude divides C1 C2 bar in the ratio R1 is to R2 internally. Internal center of similitude divides C1 C2 bar in the ratio R1 is to R2 internally, and external center of similitude also divides in the same ratio R1 is to R2 but externally. So I and E are dividing C1 C2 bar in the same ratio. So that's why these 2 points are said to be harmonic conjugate. Harmonic conjugate means 2 points divides a line with the same ratio, but one is internally, another one is externally. Then those 2 points are said to be harmonic conjugate to each other. So whatever properties are there for harmonic conjugate, we can apply here also. Okay, so these are the points. Next, if the C1 C2 greater than or equal to R1 plus R2, then only it happens like this. Next, coming to the circles will be like this. Suppose the circles like this touch each other externally, then this one is C1 and this one is C2, and this the total here, this is R1 and R2. You observe this one, C1 C2 is equal to R1 plus R2. Now there will be 2 direct common tangents and 1 transverse common tangent exist. Okay, you remember that one. If C1 C2 is equal to R1 plus R2, the 2 circles touch each other externally like this. Okay, there will be 3 common tangents, 2 direct common tangents, one is transversal common tangent. Okay, now you see one more important one is this transverse common tangent, which means you see this is nothing but internal center of similitude. This transverse common tangents we can find very easily by subtracting one circle equation from the another. We will get that equation of the line, that is nothing but common tangent. Okay, that is also known as radical axis. Okay, so these are the points here. And if the circles cuts each other, suppose the 2 circles cut each other. Next, now you see C1 C2 is less than R1 plus R2, but it is greater than R1 minus R2. Okay, this is C1, this is C1, this one is R1, and this is R2, where center is at C2. So R1 minus R2 is less than C1, C2 is less than R1 plus R2. Then the 2 circles intersect at 2 distinct points, and there will be 2 direct common tangents only. Okay, there will be no transverse common tangents, and the 2 circles intersect at 2 points, and this is called common chord. This is called common chord, which we can find very easily. The equation is also we can find very easily by subtracting one equation from another equation. We will get this common chord. It is also known as radical axis. Now, if the circles like this one, so touches each other internally, this is entire distance is R1 and this is nothing but R2. Now C1 C2 is equal to R1 minus R2. Now the circles touch each other internally. If C1 C2 is equal to R1 plus R2, then the circles touch each other externally. If it is R1 minus R2, the circles touch each other internally. Okay, and there will be only one tangent. Here is the tangent is nothing but, you see, this is the tangent. This is direct common tangent only. Okay, now this is also very easy to find. This is point of contact of two circles. So this is nothing but just you subtract one equation from another equation, you will get that equation also. Okay. Next, if circles are like this, one circle lies inside the other circle, then C1, C2 is less than R1 minus R2. Okay, one circle lies inside the other circle, so there will be no real tangents exist which touches, there will be no common tangents exist by touches these two circles. Okay, and let us suppose these are the two circles, concentric circles, there will be no common tangents. In these two conditions, there will be no common tangents. Okay, so these are the few, not only few, the maximum of the points, important points for JEE Main and Advance. I tried my level best to complete all the concepts in circles. If you like this video, you share to your friends and subscribe the channel. And if you want any more topics like this in one shot, or you can say in one class, the total complete topic revision, you just post the topic name and in description, in comment box. Okay, right, thank you very much. Thank you.